Now, I've noticed the difference between the 4800 and the 5000 is that you've expanded the range on the gain. Instead of being now 15, it's out to 20, whereas the 4800 is out just to 15 like the 4500 was. What's the advantages? Like, is 20 a higher amount of gain to what a 45 or a 4800 is, or is it just the same top out and you've just allowed more?
It's exactly the same range. So it's exactly the same range of gain settings between the 5000, the 4800 and the 4500. But what we've done is provide more intermediate gain settings, so you have finer adjustment of gain. Because really, I haven't seen an environment yet where you should have the gain on your 4500, for instance, turned up flat out.
Yeah,
it's too high, and intentionally so. If you provide all the gain settings, you want to provide gain settings that can be used by everybody everywhere.
Yeah.
And so we allow a few extras, but you shouldn't really be using gain settings up that high.
So because I do get a lot of confusion with this, what would be the recommended gain level on the 5000s, for instance? What would the numerical number be? Like, I notice under general search mode it's 11. Would that be an average gain that you'd recommend across the board? It's a starting point? It's
a good starting point, and I think more people should use their detector out of the box if they're a newbie in the factory presets. They're a good set of settings to use so that you can get used to the detector, get used to its behaviour, and then start adjusting the settings one by one. Keep liking it to a digital camera. Everybody buys themselves a digital camera, and I certainly do. They've got the little dial on top where you choose between sports and indoor and outdoor. And I think that the deep and general modes give a similar control on the GPX. So learn to use your detector in those settings, and then you can start to turn the gain up by a notch. Turn the signal...
so don't wind it out to max and then...
Definitely not. You get yourself caught up in knots when you do that sort of thing too quickly.
This probably leads to another question now. I get a lot of comment from people saying the detector is noisy. What are the different types of noise that people actually experience with their detectors that they need to categorise so they understand what causes a noise?
We have a lot of problems with that. A lot of people talk about noisy detectors, and there's actually very simple ways to categorise noise. Primarily you have electromagnetic interference.
Right.
And that's...
So EMI.
EMI.
Yep.
And that comes from the electrical environment around us, power lines, nearby operating equipment, mobile phones, all of that sort of thing. An easy way to see EMI is you hold the coil in the air, not moving. Whatever you hear that's not pure smooth threshold is EMI.
Right, okay.
So that's easy to define EMI.
That's the auto tune or manual tune where you can actually tune it out.
Exactly.
Okay.
Exactly. And then there's ground noise. And ground noise...
whatever's created by the ground?
Exactly. When you're on the ground, when you're sweeping over the ground, that's ground noise. If you're holding the detector steady over the ground, that's not ground noise. So
if you're getting ground noise, is that because the detector isn't ground balanced correctly, or is it because the detector can't deal with the noise from the ground?
Generally, the detector will ground balance and be very quiet in most grounds, particularly if you're operating over a very small range of ground. If you're moving over wide expanses of ground, then you should be, and you're getting ground noise, then you can move into the smooth timings, the enhanced, the fine gold, the
so obviously all the
smooth.
different timings offer you options about dealing with conditions.
Exactly.
Right, so that's two of your noises. Sorry, I've jumped on you.
Oh yes, I've forgotten.
I do that to you a bit. All right, so different types of noises. We've got EMI, we've got ground noise. What are the other types of noises? And
then the only other real one is detector noise, and we don't see that as an issue, but that's the one that people worry about the most, is that the detector is itself inherently noisy.
Okay.
A detector noise you can hear... And this is not something that would recommend for everybody to try all the time. If you put a monoloop coil on your detector, put it in cancel mode, obviously you wave a target over the coil, you won't hear very much at all. And so whatever you're hearing beyond a smooth threshold is detector noise.
And that's part of the electronics, is it? Or
yes. Yeah, it's inherent in
the way the Minelab machines are designed, normally you wouldn't even notice that, would you?
No.
Because ground noise and other...
Ground noise and EMI dominate, yeah. The detector noise is very much below the external noise sources.
All right then.
But that's a good way to test those three sorts of noise. You can put the monoloop on cancel for detector noise. You can put the coil in the air stationary for EMI. And then sweep the detector over the ground where there's no targets to hear ground noise.
Okay. Sounds like it might be a good subject for a blog in the future, perhaps.
I might take a suggestion and create one of those, yeah.
Yeah, why not? Okay, we've been talking about the differences between the 4800 and the 5000, and I noticed a lot of the Minelab literature now talking about 8 timings in the 5000 and 6 timings in the 4800. Could you sort of just touch base on me, what are all the timings, why so many of them, and sort of what they do?
Well, the SD2200 had timings as well, but they were inherent in the machine. So there was a single set of timings that operated the machine. And then when the GP series came out with the GP Extreme, there was more timings added. So the timings at that stage were salt and sensitive. So salt, obviously, for conductive ground, salty conditions, and sensitive timings were for smaller targets.
Okay.
And they really optimised the detector for those conditions and helped enormously. And then when we came out with the 4000, we had some more timings. And then when we came out with the 4500 and now the 5000, we've added more timings in.
Right, okay then. And those timings effectively just give the detector operator more options to choose from depending on ground conditions, etc.
Yeah. So talking to a lot of people, a lot of detectorists around the place, one big question everybody asks is, what are timings? And up till now, I haven't had a very good answer for that. And even now, my answer for what are timings is the timings are the way that the detector controls the transmit pulses and the receive weightings.
Okay.
And that's
Which
not...
is essentially what pulse induction is, isn't it?
Exactly,
yeah, okay.
exactly. And the more relevant question, I think, to ask is, what do timings do for me? When I'm out in the field, what timings should I be using? And so my definition of that is that the timings are the way the detector electronics is optimised for particular tasks. And I've got 4 groups of tasks that the detector electronics gets optimised for.
Okay.
The first is levels of ground mineralisation.
Yep.
The second is ground variability. The third is conductive grounds, special class on their own, that's salty grounds.
Okay. Yep.
And the fourth is for target size. And so the timings become like a mode switch for your detector. It just optimises the detector electronics for a particular task.
Right. And I assume that all these timings have crossover points on target sizes, for instance.
They do.
Yep.
They
Okay.
do. And Minelab have now developed a set of icons that are used to help describe the timings.
All right. So it just makes a bit more sense about depending on the type of conditions you're experiencing.
It's a way of visualising what the timings do for you.
Right.
So of the 4 tasks that the timings optimised for, the first one is the levels of mineralisation. And the icons series that we've got show the timings and their application across increasing levels of mineralisation, from coin relic in the most benign grounds through to sensitive smooth in the hottest of mineralised grounds.
Okay.
And then ground variability, you'll find there's a small group of timings in our icon series where the timings are in what I call the smooth category. They deal with variable ground very well. And that came out first in the GPX 4000 with the sensitive smooth timings. That were a great revolution, really.
Yes, very much so.
Yeah. And then for conductive grounds, we've got salt coarse, we've got salt gold for those conductive ground. And also coin relic mode, you'll find that's got application in salty grounds as well on the beach. In fact, that's where we first started developing those timings.
Right, okay.
Yeah. And target size. So obviously the ones that stand out are fine, sensitive extra, sensitive smooth. For those smaller targets, when you're looking for the small targets with what I like to say are very fast time constants.
Okay.
And so that's what timings do for you. They are like a mode switch for the detector. They just optimise the detector electronics for a particular task.
All right, excellent, Phil. Well, thank you very much for that. I appreciate you coming all the way up here to our lovely rainy weather and explaining that all for me. It's
No worries.
excellent.
It's been excellent. Thanks very much.
Thanks, Phil.